Guys, this is Luke here with the Bulldogs Robot in 30 Hours with our Day 1 recap.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
First Updates Now is supported by Kettering University. Kettering University is where robotics students come for their education. Over 30% of those who attend Kettering University were in high school robotics, and you can keep going with their BattleBots, VexU, esports, and FIRST mentorship programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more.
Overall, we are pretty excited about the game and some of the challenges it has. We started off kind of addressing the barrier. That was the main goal for a decent portion of the day. That seemed to be one of the most influential challenges on the design of the robot as a whole, since that would kind of influence how our chassis would be built and what kind of wheels we would use, that sort of thing. So we tested a 2-power wheel drive with the front 2 unpowered. That worked somewhat, but it was pretty easily stuck. We tried the tile runner. That gave us a little bit of problems, but better. We tried the Go Build a chassis and the Andy Mark tile riser chassis as well. Cole is going to get into the results of that soon. We had some work on the electrical system, made a lot of progress there, and with programming as well. We got to prototype a couple of different designs for the freight manipulator, and then we came up with a lift for that, which Nick and Howard are going to get into a little bit. Kind of decided where our direction has headed on the carousel, which Montana will talk about. And overall, we've made a decent amount of progress today. We're excited to go into tomorrow, fresh and ready. As you can see, our team members have kind of made their way out over the day, but that's okay. We're going to be strong in the morning and ready to get back at it with some more mechanisms, building, and that sort of thing. So let Jesse take it away on programming.
And by the way, if you got any questions for the Robot in 30 Hours team, make sure you take at First Updates Now. You can ask that in chat. We'll get those questions as we go through, and we'll kind of interrupt you guys as some of those questions come through. And we will have a couple giveaways starting very soon as well, too. So keep an eye out for that.
Yeah, please interrupt us if you guys have questions. I'm going to talk a bit about programming. So we haven't started on auto yet, and we need to test the freight manipulator and the carousel manipulator, but both of those are fully programmed as far as I'm aware. The drivetrain completely works. I had a small bug that we just fixed with the drivetrain, but it wasn't a big deal. So next steps for me are to go over auto and make sure that all of the manipulators that I have programmed are fully working. I'm going to pass it off to Nick now.
Hey guys, long time no see. It's Nick, and I'm going to be talking to you about some of the intakes that we've worked on today. So, most honestly of the development we did today revolved around the chassis getting over the barrier and just setting the groundwork for everything to come. But near the latter half of the day, we did start prototyping intakes that could potentially pick up the freight we need. So for starters, we've got your pretty stereotypical vertical roller intake. You just drive up into the pile of freight with this, suck one game piece up, and drive away. It worked really well in terms of getting a game piece seated in your control and not picking up too many, but it did have the flaw of you had to be pretty precise with it. You couldn't just like drive it into a huge pile of freight and always come out with one. You kind of had to single out a target and go after it. And then we also prototyped, and this is not the state we tested it in, but good enough to show the concept, a horizontal roller one. Where, I mean, same concept, but now you've just got two wheels spinning opposite each other to grab one. This also worked a little bit. It had a little bit more of a poorer showing than this one did, just because if you hit the freight on the outside of the wheels, then it would just kick the game piece away as opposed to bringing it in. And you also had to be as precise, if not more, than with the vertical roller one. We do believe the horizontal roller has potential, though, especially if you combine this with something like surgical tubing on the outside, to where it will kind of if you had surgical tubing on the outside, it'll almost wrap around the freight and try and kick it towards the middle as opposed to just throwing it away. So we will be iterating on the horizontal design later tonight, early tomorrow. But if that hits the fan and we decide that it isn't worth pursuing anymore, we will just go with what we know works and build a more refined version of the vertical roller one. That's all of the intake progress there really is as of now. We will keep you updated as more develops, but I'm going to pass it on to Cole.
Hey, we're going to start a giveaway chat if you're interested in winning. We do have a $25 AndyMark gift card that we'll be giving away, and the keyword is going to be one word, Tile Riser, talking about that new Tile Riser coming out. So Tile Riser, which we just typed in chat, type that in, and that's your opportunity to win a $25 gift card from AndyMark. Somebody asked, by the way, Cohen in chat, can the robot hold more than one cargo piece at a time?
So with either of these two prototype intakes, there just isn't physical space for it to hold more than one cargo at a time. With the wider roller, we're going to be prototyping another horizontal one that has a wider reach of collection, and we will be taking active measures to ensure that it can't hold more than one at a time. We don't want to rack up penalties.
There also was a question from Madison earlier. How many people are on the Robot in 30 Hours team?
1, 2, 3, 4, 5, 6. I think about 10. Roughly 10 to 12 overall, split up among a couple different subgroups, but we had a couple people who weren't able to make it today and a couple who are going to be back again for tomorrow. So 10-ish overall.
And there also was a general question of the age group of people here. These are all college students, right?
I think everyone here is, 19 to 21 at the moment, so pretty concentrated.
Yep. So as that giveaway keyword was Tile Riser, we're going to move into a little bit about the chassis right now. My name is Cole Jordan. I'm a mechanical engineering student here at Kettering University. For chassis today, we were looking at the AndyMark kit Tile Riser right here and a Go Builder kit. Initially, we found that the AndyMark was able to very easily scale the barriers, and you can see down here the AndyMark has a great clearance in between its wheels, and you couldn't get stuck unless you were really trying to get one of the wheels stuck in the barriers. So we really like the AndyMark's performance right out of the box. However, our Go Builder, we wanted to see how he could do, and we had some issues getting the Go Builder over the barrier. The Go Builder's chassis would originally contact the barrier before its wheels did. So you can see here we've actually modified the Go Builder chassis. We've sanded down the corners of it, and this allows us to have the wheels contact the barriers first and get over. Whereas originally he would just get stuck if you tried to go head on to it. One of the reasons we decided to modify the Go Builder chassis was we really liked the packaging of the Go Builder chassis. With this wide open space on the front, we felt that we have a lot more freedom for designing our game piece manipulation, whereas on the AndyMark chassis, we had motors at the front and back, and we felt that we would be restricted in space and in packaging. So we decided to evaluate a modified Go Builder. We were happy with the performance of that. All it took was just sanding down the edges here. We also like the general size of the Go Builder, so we've decided that we are going to be pursuing building our robot on the Go Builder.
So a couple questions about drivetrain stuff coming in. We have the Tile Runner and the Go Builder chassis that are both mechanic wheels. Any other thoughts on any different types of drivetrains potentially to use as well?
So we did initially do some testing with a older FTC bot without mechanic wheels, and we really found that there is still such an advantage with the Mecanum wheels. The maneuverability of your robot and ease in getting game pieces and in placing game pieces, we really couldn't see a reason to not go Mecanum wheels based off any other wheel type that we had available to us.
Is there the question from Lucas the Canadian in chat says, is there any way that you could just drop down the wheels on the Go Builder intake instead, or how else can you modify that chassis?
So drop down, he said?
Yeah, or remove the wheels. Yep.
One of the issues with moving the wheels on the Go Builder chassis is you are pretty limited in your availability. What?
Just the motors.
Okay. you're limited in your availability to put your wheels. You've got to line up with a couple bearing holes that are on here, and we could have moved it forward. The issue was if we moved it forward, we would then be outside of the frame perimeter, and you really can't move it down without having to really do something strange to the chassis that probably wouldn't hold up. So we decided to just sand down the corners, front and back of the robot. That was much easier, and that worked perfectly fine in our testing so far.
Talking about the barrier itself as a robot traverses. I'm sorry, go ahead.
Okay, yeah, sorry, just one more thing. Yeah, so as you can see here, I just wanted to show that you've got really nice bevel gearboxes, I must say, pretty cool overall, that go into the drive wheels. So if we were to keep this configuration instead of going with some sort of different gears or sprockets, which would have been a hassle in itself to find and get enough of, we would have had to take these motors and angle them upward so that the motors would be going like that if we wanted to make it so that the motors wouldn't be a problem for clearing the barriers. But as you can probably tell, if we made these motors go upward like that, we're sacrificing a bit of our packaging for the robot as a whole, and they kind of just get in the way of everything else. So that was another big contributor in not just moving the wheels down.
So I know we'll have a couple of videos coming out in regards to testing of driving over the barrier, but can you maybe just talk about elaborate a little bit more on what you've seen? Have you seen slipping going over the barrier? Has the robot turned as you tried going over the barrier, that sort of thing?
So we tried a couple different things when we were going over the barrier. We tried going at it at an angle, and one of the big things we just tried to do was we tried to get ourselves stuck in as many different ways as possible, whether that's jamming two wheels in the center there. And one interesting way that we figured out we could get stuck with the Go Builder robot was at the end of each barrier, there is a triangle that's sort of the bracket that holds it together, and we can actually get that triangle lodged on the inside of the Go Builder robot and get us stuck that way. So we have tried a couple different ways to get it stuck, and develop some sort of skid plate to block that, but otherwise I don't think we've had any other completely gotten stuck with it.
One last question before we move on there. What are your thoughts on the overall durability of the Go Builder chassis?
We really don't have any concern with the durability of the Go Builder chassis. As we were piecing it together, everything, the fit and finish of it all seems really nice. It seems very rigid. We really love the gear system that we had down here. Everybody who was working with this remarked that we thought it was a great system, and it's pretty robust.
All right, hi guys, I'm Howard. A lot of what I spent time doing today was prototyping a lifting mechanism. That was mainly for the second part of the day. So one of the current prototypes that we have, if Jesse would like to show it off, is what's called a 4-bar linkage. So some of you may be familiar with these types of mechanisms, some of you may not. But basically it operates on the principle that if you keep all the sides of a parallelogram the same, the opposite side stays parallel. So it has 4 pivots and 4 linkages, or 4 bars, you could say, holding it all together. So therefore, we put in one input, and it causes that entire piece to rotate out while keeping whatever intakes on the end of it parallel with the ground. So the main reason why we decided to do that, or why we decided to do a 4-bar linkage, is because we thought it would be a very good and simple mechanism to be able to lift up as well as outwards to be able to put game pieces on some of the scoring elements. So it's relatively straightforward, and it's easy to build with the parts that we had.
All right, we're going to draw for our first giveaway, which once again was a $25 AndyMark gift card. Don't forget, get your questions in chat for the Robot in 30 Hours team. And the winner of that is going to be Quinn McGinley. Congratulations to Quinn for winning that giveaway on there from AndyMark. Thanks again to AndyMark for that as well. And we're actually going to start our second giveaway as we go through the rest of this show. Here, don't forget, stick around with us after. If you're watching live, we will have more of the stream going on as well, too, so make sure you check that out. But we're going to be giving away from our friends at Go Builder a gecko wheel. It's a 96 millimeter gecko wheel for that. So if you're interested in winning that, go ahead and type in gecko in chat, Gecko, And don't forget, if you are subscribed to our YouTube channel, you can do that for free. Click that little subscribe button there. Stay up to date on everything going on First Updates Now. You get 5 times chance to win. So Gecko is your keyword as we keep moving on with the Robot in 30 Hours Day 1 recap.
All right. We got any questions or no?
All right, we'll keep going on with the recap. So this is day 1. My name is Montana, and I'm a part of the Robot in 30 Hours here at Kettering University. I am a Bulldog mechanical student. For the most part, I was doing a lot of electrical, but I was also a part of the carousel team. So I believe it was our 3rd priority to design a carousel mechanism, essentially spinning this green wheel and then spinning the carousel to then remove the duck from the carousel, not by position, but simply by rotation. We believe we have a solid opportunity to do this. We will begin prototyping tomorrow morning, and I believe by the time we recap on day 2, it will be fully functioning and wonderful. Like I mentioned, I was working on electrical. We made great progress. As you can see, the rat's nest on the Go Builda. It works. Starting tomorrow and keep going on, we will continue to make this official. Now that we have chosen the Go Builda as our chassis, we'll figure out how to wire everything, and we'll keep zip ties, keeping things nice and neat. And then, as some of you might have noticed on the live stream or seen up close, there is no power switch, so that is my next task. I think that's all we have for day 1. Any more questions?
Let's take a look in here. Somebody wants to know about the 4-bar linkage. What are you planning on using that for?
So basically what we've been working on the 4-bar linkage for is a mechanism to take the game pieces or take our entire freight intake mechanism that Nick's been working on and lift it up so that way we could take the objects and put them on each of the, whatever they're called. Yeah, the shipping hubs. Yeah. So the 4-bar should let us, as we grab the mechanism, start it low and then bring it up and out from the robot's chassis, so that way we can drop things into it more easily.
On the carousel, what motor is being used for that?
This is a Neverest. I believe it is a 60-to-1 ratio. We will be doing some testing to confirm that. It is not a nailed down science. We have some 40s and 20s that we can try out with it. It's also really easy to pick and replace this kind of motor. So stay tuned.
Last moment for questions with the team here. Of course, you can ask them afterwards as well, too, if you like. But Fizzable asking, do you have the SDK already? I'm not sure who'd be able to answer that.
Yes, we do. We're using Android Studio. I don't know how it works for OnBlock or OnBot, sorry, or anything like that. But with the Android Studio install, it comes straight with it, so you don't have to do any sort of extra work. It's right there with the packaging.
Going back to the carousel, has it been tested to see how fast you spin the carousel?
It has not been tested, and we are actually concerned about that. So we will do some programming to limit the speed in which to allow the duck to travel across the carousel as opposed to launching the duck.
What is the 4-bar linkage? What components is that made out of?
So the 4-bar linkage is made mostly out of Tetrix parts that we had. So it has a Neverest 60 gear motor right here, I think, with a 3-to-1 gear reduction to this arm. And basically this gear right here is bolted directly to this piece of aluminum without putting any torque through the shaft, so that way it doesn't bend our shaft with that amount of torque. But aside from that, it's mostly Tetrix axle, aluminum, and bushings. Which you can make it really with anything if you wanted to.
So before we wrap up and draw for that, go build a Gecko wheel. Make sure you type in Gecko once again. We don't need to do a whole round table, but any last advice for teams, starting their first day in Freight Frenzy? Any last words of advice you can give them as they get started with their challenge?
Speaking from personal experience with programming, get started early. The earlier you start with it, the faster you'll be able to run into your potential issues, even if you don't necessarily have a test bench robot to work with. And the faster you can get those done, the faster you can get all the cool stuff done, like autonomous and making sure all your mechanisms work properly.
As far as the barrier goes, there are a lot of different solutions that are going to be effective, but I'd say you are going to want at least 4 powered wheels, no matter which one you go with. The ability of the barrier to get you stuck when you only have 2 powered wheels is just immense. So make sure you're testing and make sure that you can really get unstuck with whatever solution you choose. And also prototype, prototype, prototype.
All right, we're going to draw for our giveaway once again for the Go Build a Gecko wheel. If you do win that, please shoot First Updates Now a message either in our Discord or you can shoot us an email, admin@firstupdatesnow.com with all your shipping information so we can get Go Build to get that out to you. And thanks again to Go Build and Andy Mark for the giveaways. We have more coming up tomorrow as well. Ankil Kodahala, congratulations. You have won. Please make sure you shoot us a message for that. So congrats on there. If you have more questions, feel free to ask them in chat. We'll get to them as soon as we can. How late are we staying tonight? What's the general plan for the rest of the evening?
We will see.
Okay, so it might go all night for all we know, right?
We might have someone here all night.
Yeah, so make sure you stick around, especially if it starts, getting into like 3, 4 a.m. Stuff gets weird. So, join us during that time. A couple last schedule notes for everybody. So tomorrow we'll do just a brief check-in, probably around like noon or 1 or something like that. Just see how everybody's doing on there. Get a pulse check as we count down to the final hours. 2 p.m. we're actually checking in. I'm sorry, I believe it will be 3 p.m. Eastern. We're actually going to check in with another Robot in 30 Hours team there's a few teams from Wisconsin doing that, so we'll check them out, see what's going on with them. At 7:30 p.m. Eastern tomorrow, Andy Mark is going to be on to talk about some of their new components, and they're doing AMA. If you have any questions for them on the game or new components and stuff like that, we got Nick and Liz from Andy Mark who will be talking about that. And then the reveal. 8 p.m. tomorrow is the plan, maybe about 8:15 by the time we get started. And the plan is to play a few matches. So if you're actually interested in seeing how this game is played on the field, you can go ahead and do that. One last question before we wrap up here. Thoughts on narrow bots and the idea of having a narrow robot to go through, and that comes from Mahir.
We had looked at the idea of a narrow robot because if you do get yourself within that 13 and 11/16 distance between the barrier and the wall, you won't have to worry about getting over the barrier, so you have a lot more freedom in some of your chassis design and what sort of wheels you might choose or what sort of approach angles you're looking at and ground clearance. However, if you're narrow enough to fit that, it's not just 13.7 inches that you got to be. You have to have a margin of error. You got to be able to make sure that you fit through that. So you have to be even more narrow than that. And when you're getting that narrow, you already don't have a whole lot of space on these FTC robots. If you're cutting off 5, 6, 7 inches from your current frame boundary, you're losing so much packaging. You're losing so much space for any sort of actual game piece manipulation, and also space for just the component, your main electrical, your controls. You're losing a lot of space, and you're not really gaining that much compared to keep at the standard frame and just being able to climb over those.
Also, you'll be able to see it, I'm sure, later on in the stream as well and on our YouTube, but it was pretty quick when we were just sending it over the barriers as well. So you might actually save time if you build your drivetrain robust enough to just take it full force and go straight over the barriers instead of kind of maneuvering over to the side, going in, and then maneuvering from there. So it's a lot more of a alignment if you're going that path, but if you can make it work, so be it.
All right, thanks a lot, everybody. Thanks a lot to the Robot in 30 Hours team for doing a great job so far. Lots of great progress, lots more to do, so we're going to let them get back to it. So stay tuned. We can't wait to show you off more what's going on here. Of course, Robot in 30 Hours here at Kettering University. Thanks a lot to Kettering and Stryker for sponsoring all this streaming going on here. Keep your questions going, and we're going to let these guys get back to work. Thanks to Kettering University for their support of this video. Don't just sit in class. Kettering University is the only school in the U.S. that allows you to work as an engineer your first year with their 3-month on, 3-month off co-op programs. If you are a U.S. student grades 8 through 12, scan the QR code to stay up to date on info and events happening at Kettering and get a free Kettering t-shirt when you sign up by December 12th, 2021. We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. Thank you to AndyMark, GoBuilda, and Rev Robotics for providing components and giveaways to the Bulldogs Robot in 30 Hours team. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.